Hello algebra students, Marsh here. So today we're going to look at the rational zero theorem. You're going to want your notes and then calculator and then pen or pencil today. So what happens, dun dun dun, when you're not given a factor or the hint of the polynomial like our X factor assignment had? What are we going to do? No, we're not going to freak out like that little man right there. Today we're going to find a way to solve polynomials that cannot be factored. So here's what you're going to do. You're going to find a hint because we would need to play every kind of number to be synthetically divided, right? So we're going to find a hint, and we're going to become a very educated guesser using our hints. What we're going to use is what's known as the rational zero theorem. What this is it means that every rational zero of a polynomial has to have the form of p over q. And you're probably like, that's wonderful. What's p and q? Well, p is the factors of the constant, aka the number without an x at the end of the equation, over the factors of the lead coefficient, aka the numbers in front of your polynomial. Now, just a flashback, let's kind of remember here. When we're talking rational, that means you're going to have real numbers, rationals. You cannot have square roots, that's irrational, and you're not going to have any imaginaries either. You're only going to get fractions or regular numbers and integers, so you can have positives and negatives. So let's actually use this. So first what we're going to do is we're going to look at the factors on the end and the factors of the beginning. So p over q, p being 8, q being 2. So here's what I'm going to do is I'm going to list all the factors of 8. So aka numbers that multiply to give me 8. So I believe that would be 1 and 8 and 2 and 4, right? All of those give me 8. Now let's list the factors of 2. That would be 1 and 2. Now something to keep in mind as well, guys. You can have all the positive 1 and positive 8. And then you can also have negative 1 and negative 8, right? So we got a bunch of negatives and positives. But that's for every single one of those. So we're just going to put those on our final list. Now what we're going to do is we're going to compile the list of possible rational zeros. Here's what you're going to do. You're going to put each p factor over each q factor. So first part, I'm going to go 1 over, or all the top numbers over 1. And I'm going to put some plus or minuses with them too, because I could have a positive or a negative 1, a positive or negative 8, positive or negative 2. Ooh, my pen's going wonky. Positive or negative 4. Okay, lifted all of these guys over 1. So 1 has been taken care of. Now I got to put them all over 2 as well. So I'd be positive or negative 1 over 2, 1/2. Positive negative 8 over 2, 2 over 2, and then 4 over 2 as well. Now you're probably like, hey Marsh, 8 over 2, that's just 4, right? 8 over 2 is 4. And notice, guys, we already have 4. So that does not matter. We can just kind of cross him off. We already have him in our list. 2 over 2 is just 1, which we have already in our list. And 4 over 2 is just 2, which we already have in our list. So our possible rational zeros are plus or minus 1, plus or minus 8, plus or minus 2, plus or minus 4, plus or minus 1/2. All right, so using that list, we're actually going to find the zeros. So what you would ultimately have to do is you would have to make guesses. I would have to say, maybe 2 works. And I would set up my synthetic division, and I would keep going, and I would try all of them. And if I didn't get a 0, I'd have to keep going, which is annoying. So is there a way that I could pick a rational zero? The first one, pick it. And I could have a dang good guess that that is probably one of the zeros. Well, zeros are just x-intercepts, right? So if I pull up the graph on this equation, which is right over here, I look like I have a 0 at negative 2 right there. So I'm going to make a very, very educated guess and guess that negative 2 is going to get me a 0 for a remainder. Let's see if that's the case. So let's set it up. I got 2, negative 5, negative 14, and 8. Notice nothing missing, so drop the 2. It's negative 4, negative 9, Got 18, 4, -8. Big smiley. Okay, so that -2 was a 0. Hallelujah, was able to find it. So now let's write our new equation here, new polynomial. So I got 2x squared minus 9x plus 4. Now, I bet he's factorable. So that would be 2 times 4, that's 8. Numbers that make 8, but multiply to give you 8, but add together to give me -9. I believe that would be -8 and -1. Now, since my a is 2, I do have to expand that middle term. Like that. And then do my grouping. So, looks like I have 2x. It's x minus 4. -1, so I can get x minus 4. So 2x minus 1, x minus 4. So let's actually list my factors and my zeros. So my factors, those were 2x minus 1, x minus 4, and the final one, the one that I found beginning, x plus 2, because that's how a -2 would get you, right? And now my zeros are -2. What's going to make that equal to 0? That'd be 4. And 1/2. Now notice, guys, those are my other two zeros on my graph as well. So what does the graph allow us to do? It allows us to check to make sure that we can actually pick one right away. Otherwise, I could have filled up this entire slide of me going, well, let's try 1. 1 doesn't work. Let's try -1. Okay, that's ultimately what you would have to do to be able, if you do not have the graph handy. Let's try another example. Got my graph already set up. Looks like 3 is a good number. Let's try -1. -1's easier math. Oh, we're missing an x term, so I'm going to need to make sure I put a 0 for him. Don't forget about that. Let's do my synthetic division. So -9, that's +9, that's 9, that's -9, and 0 for remainder. We picked correctly, ladies and gents. So this looks like it's 2x squared minus 9x plus 9. 2 times 9, that is 18. I think it would be -6 and a -3 to make a -9 when I add. Let's expand the middle term. Like that. Gotta do some grouping. So I'll get 2x, x minus 3. -3, x minus 3. So I'll get 2x minus 3 and x minus 3. Alright, so now let's go ahead and write out our zeros here. So I have, for factors, excuse me, x plus 1, 2x minus 3, x minus 3. And then my zeros are -1, 3/2, and 3. Now, if I would have listed my rational zero theorem, so P's over Q's, I would have had 9 over 2. So then I would have had, for 9, the factors of 9, 1, 3, and 9. 2 is just 1 and 2. So then I would have done my every P over every Q. So 1, 3, 9, and then I had to put them all over as well. So 1/2, 3/2, and 9/2. Notice, guys, these are possible rational zeros. It actually doesn't, I'm not, every single list down here, all the numbers, those are not going to give me all of the zeros. These are not all zeros. They're possible zeros. Choices to pick through, so when I'm doing my when I don't have the graph, I can pick a number and try it. So, keep that in mind. That's all of the rational zeros. If you list your possible zeros, that does not mean all of them are going to be zeros. It just means some of them are. So, avoid errors. Make sure you list all your positive and negative factors, especially when you're not given a graph. And then not every zero generated by your rational zero list is an actual zero. So keep that in mind as you are generating your P's over your Q's. And that's the end of this video. See you later, Sabers.